Hello, welcome back to BlenderSushi live noding. In this video, I'll be looking into how we can use animation nodes to arrange objects um, in the voxel kind of structure. I I probably have touched this in the older video, but I haven't gone too far, like making it into like a rigid body and then turning it into like a simulation. But I was stumbled into this topic at Blender Stack Exchange, and I was thinking, hey, why don't we try to recreate this using animation nodes? And so the basic concept is basically the same. So you want to somewhat get kind of like a voxel like structure. It looks like a cube. If you play a game like the Minecraft, where everything is made of 3D cube, you get this kind of structure. And then in this Blender Stack Exchange answer, it's proposing solutions using Blender particles. That's actually pretty much we are going to do, but we're gonna use the help of Blender animation nodes as well, just to make things a little bit clearer and a little bit more elegant, I guess. So if we are trying to set it up using just Blender animation nodes without using particles, we could set it up like this. So you just grab the template and then get a 3D grid here, and you get something like below like that. What you want to do next is actually to filter out the points positions for the instances. So basically what we got at the moment is kind of like a 3D grid positioning for each cube instance, and that's been done by this template, the one that's kind of like reddish color right here. But what you like to do is kind of filter out the objects, and you want to use a BVH3 construct as well. Let's say you want to voxelize this torus, for example. So you grab the torus and then you turn it into BVH3 construct, and then we filter out the 3D point grid using another loop. And as you can see here with the BVH3, and then it's looking at each point's position, which is the vector, and then I'll make it here so that if the condition is true, and then yes, pass it on the 3D point position. If it's not, just put it somewhere really far instead of making it like 0, 0, 0. I could of course make it like 0, 0, 0 if I'll show you what's happening. So I don't know if we could actually get rid of elements in the list inside a loop. Maybe that's not a good kind of not a good habit. I guess we keep all the objects in the list and then put the points that we don't like somewhere else. That's better, maybe. So what you got is something like this. So whenever the objects is actually inside the volume of 3D voxel grid, then we will get it to look like this. So just like this, like the Minecrafting, and each one of them is actually real 3D cube that we can use for simulation, rigid body physical simulations. So yeah, so this is if we want to use animation nodes to do it. If I guess we can just simply use Blender particles because it's much simpler and also pretty fast, but just want to show you if you want to use animation mouse, you use the BVH for that. And I think I already got the demo voxel grid using particles. Okay, so the setup will end up looking like this. Each one of the position of the object instant is taken from the particles grid arrangement. So you kind of get that for free when using Blender particles. It's really handy, I guess. So I'm actually playing back the rigid body dynamics simulations while recording, so that's why it's really quite slow. So maybe I shouldn't do that. But basically, yeah, the simulations will happen as expected. It's gonna be something like pretty much like that actually. Like if you use Suzanne and then create this kind of more complex 3D voxel, you can drop it and it looks like that. Okay, let's try doing that anyway. So let's quickly create a new Blender scene. Okay, now let's quickly do it. Yeah, basically the guy, what's his name? Anis Ahmad asked when we are using like a modifier. I think it's a remesh modifier, and then you use blocks. You get that kind of construct, kind of like a 3D voxel. But this is of course a fake, and not a fake. It's only creating the outer mesh. It doesn't have the inside mesh. And he wants to make a construct where it's based on it creates a cube for each blocks, of course. Yeah, there must be a lot of ways to do that, but for our task, we're gonna use Blender particles. Yeah, so we can leave it like that just for preview. So if you apply particles and use this object as the source, and then you turn off the physics, you don't need the physics, and you switch to volume and then grid, and then with particles start and end at 1. So all particles will be born on the first frame, and then you increase the resolutions like that, and reset it. Sometimes it doesn't quite work. Okay, let's go to the top view and then switch to orthogonal. Let's increase the particles until we get something that looks like the torus. Yeah, I think resolution of 15 is pretty good. Let's check our torus and wire. Turn it into wire. Yeah, I guess that's pretty good. Sometimes you get these extra points. Yeah, that's the thing with this particle system. Sometimes you don't quite get the voxel right, but you'll get pretty good like a voxel structure using this way, and it's pretty fast. And as you can see, you can kind of invert the grid, and you can also use hexagonal grid. That's a big bonus there. Let's save this real quick as an voxel simulation. So let's go to compositing. We have our points ready for us to create duplicate of our cube, of course. The cube, leave it as this size for now. We're gonna change it real soon. So grab the source objects with those particles, and then we already know how to do this. I'll just gonna do it from scratch. Let's get particles from objects. Let's grab that object, the torus. It has particles in it, and then we already know that we need to filter out the particle. Sorry, filter out particles. We just want the alive particles, and then now we're gonna use a particle list info. Yeah, and then we have the locations. We can tell how many particles we have by using get list length. Sometimes I always check it just in case we generate too many objects and then Blender might crash. Length, let's debug that real quick. 435. I guess we can handle 435 or make it smaller. I'll do it using, I'll just show it. So we're gonna instance this cube into each and every position of the 3D voxel. Hit W and look through the locations. And now just use the object transform output. And let's get our objects. If you use animation nodes quite often, eventually you will start to, instead of creating object lists here, you just start backward. So you know the last, you know the final result is gonna be, and then you kind of working backward. So it's kind of more advanced. So we know we're gonna instance this. We need object list, and object list is this guy. Of course, we still need to create object instancer. Grab the object, put it there, and then instances. Of course, how many is depending on the locations, the number of particles, and then we're gonna assign the locations into the instances like that. So we are almost there. The scale of each object instances need to be smaller. So there you go, 400 objects being arranged into this structure. Yeah, so we probably need to care about the physical size of for the simulations. We need to be sure about the size of each the unit size of each object's instance. This guy, see, sometimes the voxel is doing funny thing. Doesn't generate enough. Okay, let's grab our torus. I'll just make it. Okay, resolution 16. Resolution 16 is good. I'm gonna save this, save as blah blah blah. So there is an advantage actually using animation nodes. In this case, if you if we create a, it's gonna be our floor, and I'll scale it in Z. So it's that's our floor object. like that. Rigid body and turn it into passive. And then save this real quick. If I turn this guy into active rigid body, we will have simulations, but only for that guy. Okay, the rest of objects will not have the rigid body yet. Seems to be intersecting slightly, but so we don't need to get too much into the detail, but anyhow, I want that each object's instance to have the active rigid body happening. So I believe if we just turn on the deep copy, we're gonna get it right away. I forgot something. This one, outliner. So with our cube. So yeah, at the moment you see it doesn't have rigid body assigned into these objects. If I turn on deep copy now and check, still doesn't have. Maybe I just copy full objects and then now check it out. I think we should have the rigid body dynamic now. Okay, we got it here, but there is a problem with the collision. I think the collision group is not assigned into this guy. So, but the collision group itself is the, let's see. So it's called the rigid body world, and this guy is not assigned into the group, but animation node has a group. Objects from group input, create group object group operations. Object group, probably object group operations. So yeah, that's, so we got a group here, rigid body world, and then so we want to link it into each and every object. We can do it just like that. And now I think we have everything set. So just that single node is really useful in this case. And yeah, I think we have our simulation happening as expected. Cool. This guy, okay, the rotations, we can randomize the rotation slightly, or even randomize the location slightly, so it's kind of more random. Random viewer should be good. That should go into the rotate. If you want to do it like this, we always ensure that the original objects is reset. Shouldn't have any rotations. Okay, and then I believe that's pretty much it. Probably we should reset the object instancer from here. Reset source data, and we can hide this guy. hide the torus. Just end up with this. Maybe make it full 3D. Now it's a lot faster. And oops, I want that. And turn this into timeline. And play back the simulation. It might explode a little bit because some objects are intersecting, so it tries to push the objects out. But once they're happy and none of them intersecting, simulation will run, and then it's caching, and you can do baking and all those sort of cool simulation stuff, and you can have big amounts of objects, no problem. Yeah, so that's pretty much it. If you want to do this kind of like Lego structure simulations, start from like whatever objects you assign to it, and then you create the structure using animation nodes like this. Do whatever you like. Yeah, and then it will just happen. Of course, the real advantage of this is the reusability. So instead of torus, for example, you want to have maybe like a letter. Let's try a letter. Let's just write a S and then rotate it in X 490 degree, and then scale this guy like that. And I really like how Blender font object, the text objects actually works with the remesh, and then we can turn it into block or smooth it maybe. And then once we are happy with this, I just turn it into mesh, and once it is a mesh, I can then use it inside animation nodes, and then it will work instantly. So that's our source, probably a little bit bigger. Yeah, we can go there. And just source this object, and then everything will update. Okay, it still needs the particles. Okay, don't forget to reassign the particles, voxel, and then hide the original text, and just play back, and you have a new setup with simulations ready to run, and you just need to bake it and then render it out. So that's the advantage of node-based workflow. Yeah, I guess my computer is getting really slow because it's also recording, but yeah, we have everything set up, and you already know what to do now if you want to do this kind of effects. Okay, hopefully you find these video tutorials useful.